I don't believe in bugs. Well, okay, I believe in bugs, but I don't believe that we should have them. And when I talk about this, there are a lot of people that think clean room development, they think long, slow, painful, arduous process of getting rid of bugs. And that's not at all what I'm talking about. So I'm talking about not having bugs in the first place. And let's look at how we can do that. So I'm a guy that's been around. I've done a lot of stuff. I've written about some of it. That's the point of this slide. So let's talk first about the bugs. Why do we care? Right. So this is why we think we care. So this is data from a project that I was on several years ago. 2 subsequent releases. This is our financial data, weekly spend. Right. So this is a relatively large project. We're spending, in the first release, 1.2 million per week on dev and operations for the project. And you can see what it breaks out. But one of the things really to notice that is just how much of that spend is failure demand. How much there are we spending on the fact that we wrote bugs in the first place? And the second one is the next release of the project where we just didn't write the bugs. And notice, A, we spent a lot less money, and B, the money that was spent was almost entirely on strategic features. A little bit on infrastructure, and a little bit on testing and a few other things. So that's why we think we care, and it's a good, logical, rational reason. This is why we actually care. So there are a bunch of people that talk about, I'm a Greenfield team. I don't have this problem. Tell me how to prevent getting into the bugs case, but I don't really have this problem. I've seen legacy code. I've been on teams in the past that were awful, but I do TDD. I won't get there. How true is that? How many people have ever been on a project that was Greenfield and 6 months in was shipping, 1 bug every 2 months would make it to QA? Right, because that's what I'm talking about when I talk about a zero bug team. I'm talking about the teams out there like Hunter Technologies that over the course of 6 years, I talked with them every year about their bugs and what they were like and where they were at. And usually the conversation went something like, so, this year what's going on? It's like, well, we had a bug in May. But we solved and prevented that. We won't ever have one like that again. So even Greenfield teams typically have quite a long way to go towards zero bugs. And of course, all of us Brownfield teams, which is most of the space I play in, we have a long way to go towards zero bugs. So Brownfield teams. Legacy code, everyone thinks about it as, oh my gosh, it's this awful, awful mess of intertwined, gnarly things. I just want to leave it behind. I want to do a rewrite and get back to the green fields of joy. But the thing to think about, to realize is legacy code is actually really, really well designed 30 years ago, right? And then typically it evolves. And it evolves by having yet one more good idea come from the customer and have the developers have an attitude of risk aversion. Let's minimize the chance that we're going to screw something up in our design, so that we're minimize the chance that we're going to have a bug, etc. And so to do that, we'll make the least invasive change possible. And that principle of minimum invasive change is widespread in our industry. That's how we think of a lot of professional software development is, take a good design and just don't screw it up too much. But the problem, of course, is that the design was always designed for what was envisioned when they made the design. And the customer needs are always based on what is envisioned now that the other piece of software is assumed. And what could I do today? Right? And that's never part of your design. And so you tweak it, you tweak it, you tweak it. And the result is that every change makes the software a little bit worse in whatever areas that change. And of course, features tend to cluster. There's some part of your code that collects money. There's some part of your code that is of high value to your customer. There's these important chunks of the code, and then there's unimportant stuff. Where do the features get written? Consistently, they're in the area that's high value. Right? And if every time that you go and change the code, you make it a little bit worse, then consistently we're finding the place that has the highest value and is most important to our company and making that worse. And that's why our designs are all so painful to work with. So, another project I worked in a while ago. I want just a quick poll, some guesses from the audience of how many bugs do you think that this project had? Total over the course of that release, discovered by QA or by the customer, say in the first 2 years in service after the release. So this was a product that had been in service for 30 years. There was one part of this project, there were a whole bunch of parts of this project adding on features, but one part was this single method, which was 26,000 lines long. And its job was to understand the gestures of a human. So it listened to low-level keyboard and mouse events. And actually, since it's 30 years old, the way it did that was with hardware interrupts and low-level undocumented kernel APIs and all sorts of fun. Okay? So it listened to that, and from that it tried to intuit, what does the user really mean? What is their intent? And so it is responsible for all of the gestures and all of the feel of this application, which is one of the most important selling points of this application. Okay? So they needed, currently the thing listened to keyboard and mouse and understood that. They needed to add support for touch and pen and make those new input devices feel the same and don't mess up the current feeling. How many bugs do you think that this project had? Shout out some numbers. 5,000. 10,000. 6,000. 26,000. One per line. Yeah. Yeah, it was in the 10,000 range. Okay. Another project. This is in service for a little bit longer. This is obviously the next version of the same product. Right? I like these back-to-back comparisons of multiple versions of the same product. Okay, 18,000 lines times 2. See, in the previous one, they took that 26,000 lines and they managed to reduce it to 18,000 lines of code. But in so doing, they had to duplicate it because they couldn't mess it up. And it did keyboard and mouse well, and they didn't want to screw up the keyboard and mouse. So they just created a duplicate of it to handle touch and pen. But then they needed to handle things like control and holding the control key while you do the pen and so on. And there are timing issues with that. You know, I start drawing and within 1/10 of a second after I start drawing, I hold the control key. I want you to interpret that as if the human had hit the control key first because they meant it to be simultaneous. You can know because that's within the response time of a human, right? So what it needed to do was there's these two 18,000 line functions that are figuring out the gestures, and at times they do non-local go-tos and just sort of jump into the middle of the other function as they're trying to figure out what the heck the human means. Okay? So this is the starting point of this code. Right? It now monitors all of these devices. It still does the low-level kernel thing. The new spec comes in, and the new spec is this thing has been running for 33 years or more on Windows. We want it to work on an iPad and on the web. You're not allowed to listen to hardware registers on the web, and the kernel API is a little bit different on the iPad, so just fix that. Right? And of course, all the sensing of the various things was done, immediately when it was needed. So it's scattered throughout these 36,000 lines of code. So, how many bugs do you think this project had? 6,000? More than before? Okay. We'll see. So it was when working on these projects that I decided bugs just annoy me. And anything that annoys me is not worth doing. They're too exciting. So I started thinking about fire, because it's a pretty good metaphor for bugs. Like, I'm going along cooking dinner and suddenly the world explodes around me. And I'm probably injured and need to rush off to a hospital, right? So how do we deal with kitchen fires? So when one happens, they do happen occasionally. We've got fire extinguishers and we've got things set up and there's some preparedness for being able to deal with them. That's good. But the goal isn't to have a kitchen fire every day and then fix it quickly. Right? Fires have causes. If we want to not have kitchen fires, a really good idea is don't put an oil-soaked rag next to the burner. Right? Fires don't spontaneously explode. Well, they do, but it's really rare. Right? And bugs, it's the same way. Bugs have causes. Every bug is carefully handcrafted. It's an artisanal product created by a developer through hours and hours of careful, excruciatingly careful labor. Right? They don't mean to do it. Developers don't intentionally create bugs, basically ever. But we still all create them. And the question is why? What is it in our environment that sets up the most careful developer to still create mistakes and bugs? So this is a drawing from the Great Chicago Fire in the US. It's one of the many times that a US city spontaneously burned to the ground. There's a myth that it was caused by a cow. Miss O'Leary's cow kicked over an oil lantern in the shed. The garage caught on fire. That caught the house on fire. That caught the next house on fire. And within a few hours, since it was a windy day, this is Chicago, it's always a windy day. Since it was a windy day, fire roared through and many square miles of the city burned to the ground, and it was awful. Right? The truth, of course, is this being Chicago, it wasn't a cow. It was Miss O'Leary's kid, who later became a famous Chicago gangster, was running a gambling ring with a number of other neighborhood kids. Miss O'Leary came out to break it up. They fled, and one of them kicked over the lantern. So it's an even more American tale than it appears. But the cow myth comes about because a journalist had no idea what was going on, and made something up and published it in the news, and it was several days before they figured out what had happened, and by then the story had been written. So, the Great Chicago Fire. What caused that fire? Was it the gambler? I mean, that's the original spark, right? But that isn't what actually caused the fire. That isn't what caused thousands of people to die. That isn't what caused whatever it was estimated as. I think it's trillions of dollars in the U.S. in current U.S. dollars of damage. Right? It wasn't a gambler that caused all of that. It was a lack of zoning laws. Right? So, at the time of Chicago, how did we build buildings? Well, whoever wanted to build a building built one. And they'd get some land and they'd put up on it whatever they wanted to put up on it. So the problem with the Chicago fire wasn't that the barn burnt down, it's that the barn burnt down and it was really close to the house, because that's convenient, and that caught the house on fire. And once the house was burning good, that was close to the neighbor's house and it could easily spread. And with just a little bit of wind, things were close enough together that sparks and flames from one burning building would hit the next and the next and the next, and then you get a firestorm going and the whole place burns down. At At the time of this, there were fire departments, and they were very carefully preventing fire, or excuse me, putting out fires. Right? Everyone was thinking about how you put out a fire, and they showed up for the Chicago fire, and they did eventually put it out, but there was some damage caused. Right? It was not too long after this, it wasn't actually caused by this, but not too long after this, that we redefined the job of a fire department. And a fire department's job was no longer to put out a fire. I mean, yeah, they put out a fire too, but their primary job is to collect data about why the heck things burn down and prevent them. Right? And so building codes and zoning laws are all there based on the evidence of what causes problems larger than one building. Right? Fire being a main one of those. Right? And then there are a few other things as well, total urban value and happiness, and don't annoy your neighbors, all those sorts of things. But the main one, the instigator for the whole origination of building codes, was fire marshals identifying that if we could just build our cities a little differently, I'd only have to put out one house at a time. Okay. So I have no idea how many fires have been prevented by the building codes, because they don't happen. It's really hard to measure them. But the rate at which American cities burn to the ground is far lower than it was around the turn of the 19th century. When people build a building, are they thinking about fire prevention? They're not even thinking about civics or anything there. They're thinking about their building, right? But that is the moment at which they are preventing fires, or they're not preventing fires. Architects, in the actual real world architecture meaning of architects are the best firefighters on the planet, and none of them think they're doing anything about fires. So how do we prevent bugs? Because the time that we are creating the situation of bugginess is not the time when we create the bug, which means it's a different us. Right? We aren't thinking about the bugs that we are creating. So in order to talk about how we prevent bugs, I need to define two words that seem to have obvious definitions, except everyone disagrees on them. So when I say prevent, I mean it actually it's sort of an economic argument here, right? What I want to be able to do is spend a fixed amount of time, money, resource, attention, whatever, and as a result of that, ship something, a change in the organization, or a way of working, something that is a difference, that now for time immemorial will change the outcome of, or the probability of some outcome that I don't like. Okay. So to look at that, I need to understand outcome. Right? We often, again, muddle thinking, and it's very important to get really precise in this domain. If we're gonna really talk about what we can do to prevent, we have to get highly precise. Right? So I take actions, they lead to outcomes. Often when people are talking about things like this, talk about practices. TDD, I do TDD, therefore I don't have bugs. Well, really? I mean, I see a lot of teams do TDD, and I see a wide variance in the number of bugs they create. Anything from, I see some teams that do TDD and have one bug every year and a half. I see some that do it and have one bug written every 2 to 3 weeks by the team, and I see a bunch that are at industry normal levels and are writing about 1.5 to 3 bugs per developer per day. Many of which are found, by the development team, some more by QA. Those aren't all going to live, but it's the number created. Right? The practices aren't actually the actions, and they certainly aren't the outcomes. I want to tease those apart. Okay? So action leads to the outcome, but there's also a really important interpreter, because I can take the same action in 2 different contexts and get a very different result. And one of the things that we need to pay a lot of attention to here is it's very difficult, if we're talking about prevention, to change the actions. Right? How do I make a one-time spend that causes all future actions to be different so that I get different outcomes? There's no good way. Like, that's the realm of, okay, developers, just be careful. Right? Code carefully. Good luck with that. Right? However, I can take one-time actions to change the context. So that's where a lot of it's going. And of course, that's one element. Like, this is the, change the way that we have lighting so we don't have oil lamps sitting on straw in a barn. And then when someone runs, they're unlikely to burn down the barn. That's good, that prevents one thing. But what really makes bugs is when you get spread. When the barn burning down lights the house, lights the city. Right? So we want to prevent both contexts that cause initial mistakes and contexts that amplify a mistake to make it a whole lot worse. The other thing I need to define is bug. I actually also need to define the word zero, but I'm not trying, in this talk, I'm not really going to zero. We're just saying better. But bug. So my definition, my working definition, is as broad as I can make it. And if you can make this one broader, please tell me and I will update the slide for future conversations. Right? But it's anything that would frustrate, confuse, or disappoint some human, and is potentially visible, even if it's not actually been viewed, by any human other than the one who created it. So if I make a UI that's a little bit confusing and I check it into source control, and then I go, that was confusing, and I put a fix, and I check that into source control, bug. Don't tell me it's a usability thing, it's a bug, right? It would confuse a user. And it would frustrate the tech support person who has to deal with that confused user. If I write code that is hard to work with, that's hard to read, that's hard to understand, that has context dependency, do you think that will frustrate any humans? Yeah. Some other developers? The managers of those other developers? Yeah, bug. So there are a whole lot of actions that can cause bugs. Right? The important thing is the contexts, but in order to get to the context, we sort of have to talk about the actions. But the root action, the action that causes most bugs, is coding. I can cause a bug by design. I can design something that's a pain for people to work with, whether that's technical design or user interface design. Either way, I can cause a bug in design, right? But I can really cause a bug in coding. Now, I also want to call out, there are some non-technical ways to cause a bug, and those are just as important, and I am talking about those in everything I'm talking about too, even though I'm talking a lot about code. Selling is a good way to cause a bug, because recall, frustration and disappointment are on this list. A good way to create frustration and disappointment in a human is to tell them one thing and then give them something else. Right? So if your salespeople are selling what you have, no bugs. If your salespeople are selling what they wish you had, they're probably creating a lot of bugs. Right? Another source of bugs, the world changes. Something that used to satisfy humans no longer does. When Google had only a few applications out there and not everybody used them because everyone was on Apple still, everyone loved Google's products, and one of the reasons they loved them was because each product was carefully hand-tuned UI fit for purpose, right? It did exactly what you wanted in the way that you wanted, or at least that was their attempt, right? And they did a pretty good job of it. Then more people started adopting more Google products. And they started shifting their primary phones, and therefore their primary communication or computation devices, over to Google. And suddenly everyone was frustrated by exactly the same code. because now they had to learn to use many of these applications, and each one was hand-tuned in a totally different, bizarre way from all the other ones. And so the cost of learning the UI was a pain in the butt. Right? Over the course of a couple of months, Google's data, because of course they keep data on everything, their data showed that users went from absolutely loving the user experience to absolutely hating the user experience with no change in the code. The world just changed. And now, bug. So let's talk about the contexts. So there are a few things that set developers up to make mistakes. First one, if the code is unreadable. Right? This is actually the single largest cause of bug. Developers, when I talk with them, point out all sorts of causes of bug, things that the other developer over there doesn't understand. Of course, I understand it all, but the other developer doesn't. Things where the product owner tells me the wrong thing, right? Pieces of the code with weird dependencies, spooky action at a distance. But the one that they rarely point to is code that is just hard to read and understand locally. You know, that method that was 26,000 lines long, it doesn't matter whether it calls other things. If you edit that method, you're going to create a bug because it's 26,000 lines long and there is no human on the planet who understands how it works. Right? And we have, it turns out, a surprising amount of code that is unreadable. Right? There's a bunch of code that is in very long methods. Right? And once a method is more than about 20 lines, it's larger than will fit in working memory of a human. And now it's at the point where it is actually unreadable. Although interestingly, most humans think it's still readable up until a couple hundred lines. Right? So there's this nice little gap there where humans believe they know a lot more than they know, which is a wonderful way to prime a human to make a mistake. Right? So go ahead and target, if you really want some bugs, go ahead and target your functions at about 40, 50 lines of code. You'll do well there. Or make them really big. But there's another way you can really screw it up, which is a whole bunch of small functions that have no obvious relationship to each other. Right? And that's equally hard to read. You know, I open up this thing, I hit the debugger with a running live, and there's just objects everywhere and everything's calling everything, and I don't have any clue what's doing what with whom or why. Right? Also equally unreadable. So we can get to this with procedural development, and we can get to this with OO development. They're both really effective at creating unreadable code. Functional is good for that too. Like, we can make unreadable code anywhere, we're good at it. Right? But that's how most bugs get created, right? You're working on some piece of code, you've identified what it is, and as you need to edit it, you just can't quite understand it. You think you understand it, but your understanding is actually wrong. And so you do something based on your knowledge, and it has an effect based on the truth. Problem. Okay. The next one, of course, is context sensitivity, and all developers are aware of this one. And everyone that they've talked to is aware of this one. Most technical debt, when people complain about technical debt, they talk about, I take an action over here and it causes a bug over there, and testing never finds it. And testing never finds it because how could they? They don't even know what to check, right? I can't tell them what to check. That's a lot of what we talk about in technical debt. And so anytime that code is highly dependent on the context, then people will understand, even if they understand it locally, their understanding will be accurate for this context. They'll make a change on the basis of that, and then it turns out there's some other weird context they didn't know about, bug. Another big category is stuff that developers don't know, right? Whether that's your technical platform, our libraries are changing so quickly that we're always working with libraries and frameworks that we don't understand or really know. We have to. Similarly, there's sections of the code that I haven't read or worked in for a while, right? There's sections of the code that no one has worked in for a while. I've worked on code bases that are 35 years old and have 250 million lines of code in them. What percentage of that code is understood? Right? Even on small ones. You know, I've worked on small projects, but there's a couple of microservices running over here that we've mostly forgotten about because they always work. And then suddenly they stop working. Right? And now we need to go fix them, and oh, what was that again? Right? And then, of course, miscommunications. Miscommunications are really good for creating a bug. When a customer has a problem and a thing that they're trying to achieve, but they're unable to actually describe what it is that they're trying to achieve, so they describe as best they can, and the product owner goes, I've got it, and says, we need this. Good chance there was a miscommunication there, and at that point, we're going to have a bug. Like, it's already happened, it just hasn't turned up yet. So then there's the spread, situations that make a mistake worse. You can have all these sources of mistake. If they cause a mistake, but you catch it before it really becomes a bug, okay, I can't read this code, but I realize I can't read this code, so I refactor the code to make it readable. Right? I didn't introduce a bug. However, there are things that will cause me to spread that until it gets to a bug, or maybe a whole bunch of bugs. The first one, of course, is hurrying. This is the other developer mantra. We have too much technical debt. Shut up and stop giving me features. I need to slow down to speed up. Right? And there's some truth to that. Hurrying is a really effective way to take one mistake and turn it into a raft of bugs. That said, there are often many sources of hurrying, and in a lot of the organizations I've worked in fact the majority of them that I've worked in, the pressure did not come from management. It did not come from product owners. It came from inside developer culture. There are certain norms and expectations of how we work as developers that reinforce hurrying. And to the degree that managers who are aware of this and attempt to shift the behavior, still struggle. I had a time at Tableau, where I'm working now, where there was a piece of code being checked in by a developer, sent out for code review, and he sent it out among other people to a manager on one of the neighboring teams, because the guy's a coding manager, good guy to do a code review. He looked at the thing and said, oh, okay, wow. Okay, it might be right, but technically, like, the design is awful. And so I went and had a conversation, and the response was, yeah, I know it's awful. It's really bad, but we're in a hurry. I really want to get the feature out. This is the last thing. I don't want to fail my team. I don't want to cause all of us to slip the feature because I can't get this one thing in. We'll fix it right after the release. Right. So his response was, I know your manager. Let me go talk with him. Because we have this mantra across the company right now. Our most important feature is to continuous delivery and get things going, right? And so for that, we need people to take the time and do it right. And the response of the guy was, yeah, my manager's been telling me that. In fact, he told me that it doesn't really matter whether we hit this feature, and the product owner said that the customers aren't going to look at it until November, but I can't fail my team. This is a hard problem. There are several other sources of spreading it. Any place that we're operating with a high risk of change. Repeating mistakes over and over. But one of the key ones there is accepting errors, and that's what I'm hoping to shift with this talk. Like, I'm an edutainer, right? This is for fun, but it might have some impact on the way you work. And of all of the things that I'm talking about here, the only one that really can shift by you right now in this room is whether you accept errors. We're going to talk about all the other ones, because if you choose not to accept errors, you're going to need to then be able to figure out and address those as well. But this is the one that you could actually do something about right now. So, first thing to keep in mind is that people notice very little, and habit drives most actions. Right? So, I can't really change people's actions. I can change people's habits. And the results that we get as a team are not the result that people do when they're on their best behavior or when they're trying hard or when they pay attention. the results we get are the accumulated things that happen when we don't notice. Right? We will make a decision many, many times in the automatic way for the few times that we do intentionally. Right? So if we want to shift the outcome, we really have to shift the behaviors and the habits. And that's the real tie-in to the theme of this conference, right? Agile is in your DNA. The results that you get are not based off of what we try or our practice or this cool new thing that I heard at the conference. They're based off of the social norms, the internalized habits, the expectations, what I'm fluent at, right? So whether you are Agile has nothing to do with what you can say. It purely has to do with when you don't think anyone's looking and you aren't thinking about agility, how do you behave? So, unreadable code, right? So I'm going to be talking a bit more about this, like going in depth on it, this afternoon when we're doing the legacy code. But the key thing here is read by refactoring, right? We think of design as a write-time activity. I do code design when I write code. As long as I'm doing that, I'm operating from the wrong frame of mind, because I'm doing design when I have full knowledge and awareness, and the design is going to be consumed by everybody in the company who has no knowledge and awareness. And so my data and my norms and expectations don't align with my readers, and I'm going to confuse them. Bug. Right? So read by refactoring is, let's do design at read time when we actually match the understanding of the other consumers. And that has a whole lot of implications about how you think about design and what refactoring is, and you really have to do disciplined refactoring the way that Fowler wrote about it, and not refactoring the way that many people read what Fowler wrote. So we'll talk more about that this afternoon. Context sensitivity. Lots of people talk about dependencies, and there's the solid principles and dependency inversion and whatever else. If you really want to eliminate context dependence, you have to do dependency elimination. Right? You have to identify what the dependencies are, take the implicit ones, make them explicit, and once they're explicit, get rid of them. And that forces you to really change your design. TDD alone doesn't really help much. The workhorse here is refactoring, actually changing the design. Right? And there's some more stuff about how to do that. What developers don't know. Okay? The big thing here is, again, we're going to shift the learning not by what we change when we think we're making a change, but what are the norms and habits that cause learning to happen when we aren't paying any attention. Right? Pairing and mobbing spreads knowledge around your team by accident. That's where the value is. You can go to a whole lot of conferences and a whole lot of training seminars, and I teach training seminars, and you can listen to a whole lot of coaches, and I'm a coach. And you will get very little compared to what you will get with a few days of mobbing with people who are just, other developers around you. With the customer, or with the communication, the main thing is shorten the path. There's going to be loss of information at every hop in communication channel. So if the path information takes to get to a developer from a customer is customer to buyer at the company, to salesperson, to product owner, to development manager, to developer, and the best known modes of human communication that we have are around 80 to 90% lossy, 0.1 to the fifth, not much information is getting through. Right? If, however, I have customers go out on site and or have developers go out on site and observe what customers are doing, and then do short prototypes like while they're there and have a conversation with the customer, 0.1 to the first is a lot better. And obviously that won't be my only way of doing communications, but shorten the paths. Hurrying. Yeah, we talked some about it. This is a big cultural problem. I'm happy to talk with managers about things that you can do to help shift this culture, but it's also one that, You need to get alliances between managers from the exec level down and developers, and really pay attention to what is it in our culture that's causing hurrying to be an adaptive strategy. Right? We hurry because it works well for us. Even though it has all these other side effects, it's still of total benefit. What is causing that? Right? And that's going to be a different answer everywhere in each individual culture around. Right? And that's what you have to change. This is the one that you can do something about right now. So the first thing is we have a lot of strategies and a lot of structures in the way that we work that are about accepting and working with errors. Bug triage. Who does bug triage? At your companies. Anyone? Like, you have a whole bunch of bugs, and every so often you go through that set of bugs and figure out which ones we're going to do something about and which ones we're going to continue to ship to the customer? Okay, now we've got a couple of honest people, right? Right? Yeah, bug triage is an adaptive strategy for having bugs. And every one that you won't fix or by design causes more in the future, right? I've worked with a number of teams that their attitude to bugs is we count days since last industrial accident, right? So we treat a bug as an injury accident, and they should happen about as often as someone falling in a vat of acid at a factory. Rarely, right? And so when we're tracking, instead of having a bug database of here are all the times that people are currently being injured, we want to have a sign that says, it's been 4 days, or it's been 40 days, or it's been 18 months since the last time anyone was, right? And really focus on how do we get that number up, right? Eliminate all of the bugs, and then increase the days between creating them. For repeating mistakes, 5 whys, 15% solutions. Like, when you have a mistake, don't just fix the cause, or don't just fix the mistake, fix the cause and the cause and the cause and the cause. Right? Nancy van Schoenvert's paper, what was it, Agile Development by the Numbers with Newbies, is a wonderful example of this. She takes a team of complete newbies, and over the course of a 5-year development project, they have around 50, I've forgotten the exact number, bugs total. Right? And it's because every time that they have a mistake, and there's some pretty obvious mistakes with a team of complete newbies, they fix all the root causes, and they don't have anything like that ever again. A lot of the way we work causes a lot of mistakes. The difference between refactoring and disciplined refactoring is the risk. Right? And if you want to hear more about the difference there, come talk to me this afternoon. I know there are a lot of non-coders in the room, so I'm going to take this to a smaller room where the coders can talk about how we can actually reduce the risk of the development activity itself. So there's 2 key things if we want to prevent bugs. Number 1, focus on fixing the environment that is causing the errors. Right? Although bugs are actually handcrafted by the developer, they are not caused by the developer. Although they are discovered by QA, they are not caused by QA. Right? They're not even caused by customers. Right? Bugs are caused by the environment and the context and the way that we set up and organize our companies and our code and so on. And number 2 is learn from each bug to prevent more. If every time we have a bug, we plug something else into that socket, we're going to have more bugs. If every time we have a bug, we identify what caused this, how did we set ourselves up to make this mistake, and we eliminate that thing that's setting us up, then over time, we can get rid of all the bugs. Thank you. So I just wanted to point out those 2 things, those 2 graphs that I gave earlier, the graph and the quick poll, those are the same team. That team that was doing 2 functions, 18,000 lines long, they released over the course of that project 3 bugs.